everybody. So in this video I am going to explain about organic compounds containing C, H and O. That is about aldehydes, ketones, carboxylic acids, alcohols, phenols and ethers. So first we will discuss synopsis points. See, first we will discuss mechanism, next aldehydes, ketones and carboxylic acids main topic. So first, alkenes react with water in the presence of acids as catalysts to form alcohols. Very important. So alkene C2H4 reacts with H2O in the presence of acid to form corresponding alcohol. So here mechanism is given by first protonation of alkene to form carbocation by electrophilic attack of H3O plus or H plus. That means you can write CH2 double bond CH2. So first electrophilic attack it gives. So migration will be like this. This gives CH3 and here plus carbocation intermediate. Carbocation. Next attack of water molecule H2O, you can write like this, on carbocation results in the formation of CH2, CH3. So here O, H2 plus. Next after that minus H plus it gives CH3, here CH2 and here OH, alcohol. So very important. Here alkene, first in the presence of acid gives carbocation. So next attack of water molecule on carbocation results in the formation of O plus oxonium ion. After deprotonation gives alcohol. So that is given here. Protonation first step. Next nucleophilic attack of water on carbocation. Next deprotonation to form alcohol. Next similarly diborane reacts with alkenes to form trialkyl boranes as addition product. So these are oxidized with hydrogen peroxide in the presence of basic medium will give alcohols. So this is nothing but hydroboration followed by oxidation. So this is nothing but anti-Markovnikov's addition of water. Anti-Markovnikov's addition of water to alkene. So with the sodium borohydrate or lithium aluminum hydrate, these are powerful reducing agents. Aldehydes will give primary alcohols, ketones will give secondary alcohols. That means RCOH with lithium aluminum hydrate or NaBH4, sodium borohydrate will give RCH2OH. So aldehyde gives primary alcohol. Next similarly ketone will give RCOR. Ketone will give with the same reagents RCHOH or secondary alcohol. Secondary alcohol. Primary alcohol from aldehyde, secondary alcohol from ketone. Next, chlorobenzene fused with NaOH in the presence of high temperature and pressure forms phenol. So this is nothing but dose process for the preparation of dose process. Dose process for the preparation of phenol. So this is the equation. Next. So benzene is sulfonated with oleum to form benzene sulfonic acid. So it will be converted to sodium phenoxide and treatment with sodium hydroxide. On acidification gives phenol. That means first conversion of benzene to sulfonic acid. Next with alkali it gives sodium phenoxide. After that on acidification gives phenol. Next, high boiling points of alcohols are main due to presence of intermolecular hydrogen bonding. So which is not present in ethers. In alcohols, hydrogen bonding is possible. Intermolecular hydrogen bonding. Therefore, when compared to ethers, alcohols will be having higher boiling points. Next, propanol has higher boiling point than hydrocarbon N-butane due to intermolecular hydrogen bonding. In propanol, hydrogen bonding is present. Next, see, solubility of alcohols and phenols in water due to ability to form hydrogen bonds. So, alcohols can form hydrogen bonds with water as well as phenols. Next, solubility decreases with increase in size of alkyl or aryl groups. Next, reactions of phenol with metals will give acidic nature of phenols. Reaction of phenol with metals, active metals, indicates acidic nature of phenols. That means phenols are weakly acidic. Next, hydroxyl group in phenol is directly attached to sp2 carbon. sp2 carbon, which is somewhat electron withdrawing group. Next, reaction of phenol with aqueous sodium hydroxide indicates phenols are stronger acids when compared to alcohols and water. Remember this point, very, very important. Next, due to higher electronegativity of sp2 carbon, so to which phenol is attached, electron density decreases on oxygen. Therefore, that can release proton very easily. So the OH, it gives phenoxide ion O minus plus H plus. This is phenol and phenoxide ion. So which is stable due to resonance. Since phenoxide ion is stable, phenol can release H plus ions easily. It indicates acidic nature of phenols. Acidic nature of phenols. Very, very important. Phenoxide ion is stabilized by resonance. Next. So presence of electron withdrawing groups, that means like NO2 group, CN group, enhances, that means increases the acidic strength of phenols. If electron withdrawing groups are attached to benzene ring, then phenols will be more acidic. Next. So this effect is more pronounced when electron withdrawing group is present at ortho and para positions. Very, very important. Next, strong oxidizing agents like acidified potassium permanganate used for getting carboxylic acids from alcohols directly. So strong oxidation of alcohols will give carboxylic acids. Next, CrO3 in anhydrous medium is used as oxidizing agent for isolation of aldehydes. This is mild oxidizing agent. So strong oxidation, it will give carboxylic acids. Mild oxidation gives aldehydes. Means you can write like this. If it is primary alcohol, oxidation will give first aldehyde. Next, on further oxidation, it will give carboxylic acid. Carboxylic acid. So here mild oxidation up to this, and from alcohol to acid, strong oxidation. Mild oxidizing agent, strong oxidizing agent. Remember these two. Next. So better reagent for oxidation of primary alcohols to aldehydes is pyridinium chlorochromate. Pyridinium chlorochromate. Or we can use PDC, pyridinium dichromate also. Next. So OH group attached to benzene ring activates phenol towards electrophilic substitution since it is Electron donating group OH enhances the reactivity towards electrophilic substitution. Next, ortho and para isomers can be separated by steam distillation. That means orthonitrophenol and para-nitrophenol can be separated by steam distillation. O-nitrophenol, that means orthonitrophenol is steam volatile due to intramolecular hydrogen bonding, while para-nitrophenol is less volatile due to intermolecular hydrogen bonding. So due to difference in nature of hydrogen bonding, these two are separated with steam distillation. Next. So phenol is treated with sodium hydroxide and carbon dioxide forms salicylic acid. This is coal-based reaction, repeating question in competitive exams. Phenol with sodium hydroxide and carbon dioxide to form salicylic acid. Very, very important. Next. Orthohydroxybenzoic acid is main product. Orthohydroxybenzoic acid is nothing but salicylic acid. This is the formula. Next. Phenol reacts with chloroform in the presence of sodium hydroxide forms salicyl aldehyde. So this reaction is Reimer-Tiemann reaction. So salicylic acid, coal-based reaction, salicyl aldehyde, Reimer-Tiemann reaction. Next, reduction of phenol with zinc dust gives benzene. Next, oxidation of phenol with chromic acid produces conjugated diketone, which is known as benzoquinone, parabenzoquinone. Next, when alkyl halide is allowed to react with sodium alkoxide to form ether is known as Williamson's ether synthesis. So alkyl halide and sodium alkoxide gives ether. Next. See, enizole reacts with alkyl halide and acyl halide in the presence of anhydrous aluminum chloride. That means AlCl3. So this is best example for electrophilic substitution. So major compound is para. So here also same. Major compound is para. Enizole is methoxybenzene. This is enizole. Next. So nitration of enizole. Enizole and nitration with nitration mixture will give 2 nitroenizole, 4 nitroenizole. So here also major compound is para. Next. Aldehydes, ketones and acids. So benzene is treated with acetyl chloride in the presence of AlCl3 forms acetophenone, which is ketone. So this reaction is famous reaction Friedel-Crafts acylation. Here preparation of ketones. Next, aldehydes do not have alpha hydrogens are treated with concentrated NaOH undergoes disproportionation to form alcohol and carboxylic acid salt. This reaction is Kennedy's reaction. Aldehydes which lack of alpha hydrogen can form alcohol and carboxylic acid salt. Kennedy's reaction. The formaldehyde gives methyl alcohol and sodium formate. Next, aldol condensation. When aldehydes are ketones with alpha hydrogens are treated with dilute alkali, undergoes condensation to form beta hydroxyaldehyde or ketone. This is known as aldol condensation. See here, 2 moles of aldehyde having alpha hydrogen in the presence of dilute base forms. So beta hydroxy, here this is alpha and beta hydroxyaldehyde. So for ketones, beta hydroxy ketones will be formed. So this compound is commonly known as aldol. So aldol means aldehyde plus alcohol. 2 functional groups are present. Therefore aldol. Aldol is compound name. So when aldol condensation is carried out between 2 different aldehydes or 2 different ketones, it is crossed aldol condensation. So in this process 4 different products will be obtained. based on mechanism. Next, acid salts are heated with soda lime and loses CO2 to form corresponding hydrocarbons. This reaction will be famously known as decarboxylation. Sodium acetate with soda lime gives CH4 and Na2CO. So here function of CaO is drying agent. Since NaOH is hygroscopic, so for drying NaOH, CaO can be used. Carboxylic acids having alpha hydrogen are halogenated in the presence of Cl2 or Br2 in the presence of red phosphorus to give alpha halocarboxylic acids. This is famously known as HBZ reaction. That means HBZ reaction is simply alpha halogenation of carboxylic acids. Acetic acid with Cl2 in the presence of red phosphorus gives trichloroacetic acid. Next, carbonyl compounds undergo nucleophilic addition reactions. So carbonyl compounds with HCN will form cyanohydrins. Next, aldehydes react with 1 mole of or 1 molecule of alcohol to form hemiacetals. When aldehydes are treated with 2 moles or 2 molecules of alcohol, acetals will be formed. So aldehyde plus 1 mole of alcohol, hemiacetal. Aldehyde plus 2 moles of alcohol, acetals. Next, carbonyl compounds are treated with semi-carbazide to form semi-carbazones. These are nucleophilic addition and elimination reaction. Addition-elimination reactions. Next, when carbonyl compounds are treated with hydroxylamine, they can form oximes. Next, so presence of electron withdrawing groups, acidic nature of carboxylic acids increases. So in phenols also similar. Next, so presence of electron donating groups, acidic nature of carboxylic acids decreases. Next, equimolar mixture of copper sulfate solution failing A and sodium potassium tartrate failing B is known as failing solution. So when aldehydes are heated with failing solution, it gives reddish brown PPT. See here it is given. So in failing test, Cu2 plus ions will be converted to Cu2 or red PPT. Red PPT. Ammonical silver nitrate solution is known as Tollens reagent. Tollens reagent. When aldehydes are heated with Tollens reagent, it gives silver mirror. So a Tollens reagent will be converted to Az. That means Az plus is reduced to Az, 0. And aldehyde is oxidized to corresponding acid. Next. So in benzoic acid, electrophilic substitution takes place at meta position because acidic carboxylic group is meta directing group or electron withdrawing group. Next, acetic acid treated with halogenating agents like PCl3, PCl5 to form acetyl chloride. Next here, acidic strength of different carboxylic acids given, decreasing order of acidic strength. So when electron withdrawing group is attached to carboxylic acid, acidic strength increases. If donating group is attached, acidic strength decreases. Next, when compared to phenols, carboxylic acids are more acidic. Next, organic compounds containing nitrogen. That means here we can discuss amines, types of amines and diazonium compounds, cyanides, isocyanates also. Next, so here amines, preparation and properties. So here amines are alkyl or aryl derivatives of ammonia. So here we can write, if it is RNH2, primary amine. If it is R2NH, secondary amine. It is R3N, tertiary amine. If it is R4N plus, quaternary ammonium salt. Quaternary ammonium salt. These are different types. All these are derivatives of ammonia. Next, preparation. So, nitrobenzene is reduced to aniline by H2PD. That means catalytic hydrogenation or metal acid reduction. Next, the process of cleavage or breaking of CX bond of alkyl halides by ammonia is known as ammonolysis. So, reactivity order of halides Ri, Rb or Rcr. As the bond length increases, reactivity increases. Next, nitriles, that means cyanides on reduction with lithium aluminum hydride will give corresponding primary amines. Next, amides on reduction with LiLH4 produces primary amines. Reduction of cyanides and reduction of amides will give primary amines. Next, phthalimide on treatment with KOH followed by heating with alkyl halide and alkaline hydrolysis can produce primary amine. This reaction will be Gabriel phthalimide synthesis. So, most important preparation for primary amines, only aliphatic primary amines. Next, amides on reaction with Br2 in the presence of potassium hydroxide forms amines, which is known as Hoffman bromamide reaction or Hoffman degradation reaction. So here amide will be converted to, amide means RCONH2, amide or acid amide with Br2 in KOH forms RNH2, which is amine. So here CO will be converted to CO2 in mechanism. Next, properties. So order of boiling points of isomeric amines. Isomeric amines. The first primary, next secondary, next tertiary. Next, order of basic nature of amines. Basic nature. So in case of methylamines, secondary highest. After that primary, next tertiary, next ammonia. Next, all amines are behaving like Lewis bases. They can donate lone pairs. Next, amines on reaction with alkyl halides form alkyl amines, which is known as alkylation of amines. Next, amines can react with acid chlorides or anhydrides to form amides. This reaction is acetylation or acylation. Next, amines react with benzoyl chloride to form benzanilide. This is benzoylation. Alkylation, acylation and benzoylation. So these are important properties of amines. Next, this is the end of the chapter. In the next video, I will explain one more chapter. All the best and thank you.